We are currently suffering from two major problems. One is skyrocketing electricity prices. Another is water scarcity. We can address these problems by utilizing wasted rainwater. Assuming 100 millimeters of precipitation in a month, we have calculated the amount of rainwater that falls on the rooftops of buildings in Seoul. The result was surprising: 260 million tons. 260 million tons is equivalent to 65 Wembley stadiums in London. Our pipe generator, Aquafy, is a device that can make use of this surplus water. The basic mechanism of Aquafy is similar to that of hydroelectric power plants. As rainwater flows, it spins the turbine and generates electricity. The potential energy of water is converted into kinetic energy, which spins the turbine and thus causes electromagnetic induction to convert the rotational energy into electrical energy.
Furthermore, a filtration system is attached inside Aquafy, meaning rainwater will be converted into usable water. There are two types of filtration systems inside Aquafy. One is a filter that allows ultrafiltration and removes particles that range from 0.01 to 0.5 microns. Once the water moves through the ultrafiltration system and the turbine, it will finally reach the microfilter system where small particles will be separated from the rainwater. After filtration, the water will be distributed to buildings, which can be utilized for bathroom facilities and various cleaning purposes. These images are the 3D modelings of our generator. We make the overall structure of Aquafy similar to that of a jet engine, connected external batteries, and design each end to have the shape of a screw thread. Also, the turbine wings of Aquafy are small because this way, Aquafy is able to operate with 8 to 10 millimeters of light rainfall. In order to fill the power gap within our generator, we decided to use a series of battery connections. By connecting the waste batteries in a series, we could generate more power. We are planning to launch a campaign to collect waste batteries from the community and distribute it to our customers every 2 weeks. Also, by attaching IoT platforms such as Arduino and Raspberry Pi, we can utilize Aquafy as a smart flow meter, operating without an external power supply connected and acting as a smart grid. Through experimenting with our first prototype, we realized that the water flowing in the pipe increased the power generation capacity. However, our first prototype had two main problems: low power production and weak turbine blades. As you can see from the graph, at the maximum flow rate 1.5 liters per second, about 3 watts of power was generated. Also, the blades of our turbine were so weak that it quickly broke when placed in water with a high flow rate. We made our second prototype, and the following were the adjustments. First, we added a circular support that wraps around the entire turbine blade and changed the material of our product to prevent blades from easily breaking. Second, we adjusted the number of gear teeth to amplify the motor's rotational speed. This way, we could generate greater power at the same flow rate. We are planning to utilize Aquafy in 3 different ways. First, as previously mentioned, Aquafy will be used in households as a rainwater pipe generator. Second, Aquafy can be attached under the bridge and function as a smart EnerBridge. Thirdly, as Aquafy incorporates IoT platforms, we can utilize it as a self-powered, innovative flow meter.
Our primary target would be individuals living in areas with high energy costs and high precipitation rates. Our secondary target would be individuals living in areas lacking access to stable energy sources. Our tertiary target would be companies seeking sustainable development. We will implement Aquafy to low-income groups for free. By this, we can experiment with the practicability of Aquafy and build a positive corporate image at the same time. The initial cost will be shared with other companies through partnerships. Our key partners would be utility companies and non-government organizations related to the environment and energy. We will develop our relationships with customers through workshops or education programs. Also, we have 3 main revenue streams. We will directly sell products through partner companies, license Aquafy technology to them, and receive government subsidies. Our cost structure would include production, marketing, maintenance, and development costs. Join us in making a sustainable future.